So, welcome to our final video on introduction to reading the ECG. And what we're going to do in this video is read a few ECGs and talk a little bit about what's normal and variations of normal. Okay, and we're going to be using some of the techniques that we spoke about already. And we'll be reading the ECG in this order: rate, rhythm, axis, and then the waves, segments, and intervals. Okay, so this is ECG number 1. Right. And firstly, the rate is, so let's count the rhythm strip: 1 2 3 4 5 6 7 8 9 10 11 12, and we multiply 12 by 6, so that's 72 beats per minute. Okay, in terms of the rhythm, what we have done so far is that we have spoken about what constitutes sinus rhythm, and that's what we'll be focusing on in this video. In the next chapter, we'll be speaking about detailed rhythm analysis and how to identify the different types of rhythms. So for this video, we're just focusing on is this not sinus rhythm. So we said sinus rhythm is raw. Okay, so the rate, right, 60 to 100, so that is satisfied. Is it regular with P waves before every QRS? All right, so yes, there are P waves before every QRS, so this is satisfied. The P wave axis, so are the P waves upright in leads 1, 2, 3, and AVF? Lead 1, lead 2, 3, AVF. So that is satisfied. What is the width of the PR interval? All right, let's pick one. In lead 2, it's clearly less than 0.2 seconds. So that's satisfied. And what's the width of the QRS? Is it narrow? This QRS is about, at max, maybe 2 small boxes or 0.08 seconds. So that is satisfied as well. So this is a sinus rhythm ECG. So far we said this is a sinus rhythm ECG at a rate of 72 beats per minute. So the next step would be to check the axis. So in lead 1, we can use our thumbs. So lead 1 is our left thumb, AVF is our right thumb. So lead 1 is positive, so thumbs up, and lead AVF is positive, which is a thumbs up as well. So we know 2 thumbs up, that's a normal ECG. So this is a normal axis. So now we're going to look at the waves, intervals, and segments, or wave segments and intervals. And we haven't gone into great detail about the P waves in terms of chamber enlargement, but we're just going to look grossly at V1 and lead 2, and these are grossly normal P waves, right? Then we're going to look at the PR segment, which we would have analyzed for, the PR segment is not really depressed, and then the PR interval, which we already analyzed as it relates to the rhythm, right? And the PR interval is not prolonged, right? The PR segment, when you're looking at the PR segment, you're going to look at all the leads, but especially in lead 2 to see if it's depressed. And here I would say it's a little downsloping but not significantly depressed, so I would say that's all right. Then the QRS complex, you're going to analyze it as QRS. So first, are there any Q waves? Well, yes, we can see a few Q waves in V6, V5, lead 2, AVF, maybe lead 3, none in lead 1, and none in AVL. But these Q waves are tiny and narrow, so we can say these are septal Q waves in keeping with normal. Then R. What's the R wave progression like? Okay, so we said that the R waves in the precordial leads should be getting more positive as we go along the precordial leads, right? And the transition point should be around V3 or V4, and the R wave in V3 should not be less than 3 small boxes in height. So the R wave progression checks out. Okay, and then for S, in terms of the size, we would speak about, is there any evidence of hypertrophy, and is there any evidence that it's a wide QRS? So we haven't spoken much about hypertrophy, so we'll skip that. And we have already spoken about the QRS complexes being narrow, so that it checks out. Then we're going to check the ST segment for elevation, and there is perhaps borderline elevation in V1, V2, and V3, but this is within normal, right? It's normal to see mild elevation, especially in V2 and V3, and we'll speak more about that in detail in coming lectures. What I would like to point out, which unfortunately I'm surprised I didn't even mention it in the video on the ST segment, is that how do you measure ST segment elevation? Well, the end of the QRS complex and the beginning of the ST segment is called the J point. Alright, so that's the point at which it changes direction, and that is where we measure the beginning of the ST segment. Right, so we measure ST elevation at the J point. There are some schools of thought that measure it differently, like 1 or 2 small boxes from the J point, but this is a bit advanced. So for the purpose of this video, we'll measure ST elevation at the J point, right? And we compare ST elevation, or we compare the J point to the TP segment, which is not spoken about much outside of analysis of the J point, right? So some persons make the mistake of measuring the J point in relation to the PR segment, right? And there are some schools of thought that do believe that this is an okay approach. So again, this is a bit of an advanced discussion, but most persons won't fault you for measuring ST segment elevation at the J point in comparison to the TP segment. So for example, zooming in here, the isoelectric line, and this is the TP segment, and it's a mostly isoelectric line, and this would be the J point. So in this lead, there is basically no ST elevation or depression, or if there's any depression, it's minimal at best. Okay, so looking back at the precordial leads, we can see, so this is V2. All right, so the TP segment is downsloping a little bit, right? And this would be the J point. So there is very mild ST elevation at the J point. Okay, but it is in keeping with normal. And finally, not finally, but next we would look at the T waves in all the leads, right? And on this ECG, there are no T wave inversions except in AVR, and that's normal. It's normal to have T wave inversions in AVR. And then finally, we can measure the QT interval. And let us pick a lead such as lead 2. Okay, so the QT interval from here to here is clearly less than half the RR. So this QT interval is grossly normal. So we can conclude then that this is a normal ECG. So normal sinus rhythm ECG at a rate of 72 beats per minute, normal axis with normal septal Q waves, normal R wave progression, right? Narrow QRS complexes, and no T wave inversions, and a normal QT. All right, so let's try another one. So this ECG, let's do the rate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 times 6 is 108. So this is 108 beats per minute. Let's check the rhythm. Is it sinus rhythm or not? So rate greater than 100. So already it can't be normal sinus rhythm. Okay. Okay, so the RR is 0.6. So the square root of 0.6 is 0.774, right? So we're gonna divide 0.28 by 0.774, and we're gonna get 0.361. Right. So depending on whether or not this is a male or female, this could be a normal corrected QT. Alright. So interestingly enough, the QT looked like it could be prolonged when using the shortcut method in this patient who's tachycardic. But when we calculated the corrected QT, we realized that it's actually within the normal range, if not a little bit short. Okay, so this next ECG, the rate is 1, 2, 3, 4, 5, 6, 7, 8. 8, 6 is 48. Alright, so rate, rhythm. So the rate is 48. Right? There are P waves before every QRS. What's the P wave axis? It's P waves are upright in 1, 2, AVF and 3, so there's a normal P wave axis. The PR intervals are normal and the QRS is narrow. So this meets all the features of sinus rhythm except for the rate. So this is a sinus bradycardia, and this can be normal in athletes and young persons, right? Like children and teenagers and even young adults, right? And should not be concerning unless the clinical circumstances indicate that this might be pathological, right? Or if the patient is elderly, it's more likely to be pathological. Okay, so rate, rhythm, axis. Lead 1 is upright, so that's a thumbs up, and AVF is upright, so that's a thumbs up. So it's normal axis. All right, and then now the waves interval segments. So the P waves look good in leads V1 and lead 2. The PR segment is not depressed in any of the leads, right? The PR interval is okay. The QRS complex is now, there are tiny Q waves in V5, V6, AVF lead 2, and let's see, lead 3. Alright, so those are septal Q waves, and that's okay. What else now? The R wave progression is normal, and in terms of the width of the QRS, it's narrow. Okay, there are no T wave inversions on this ECG, oh, except for V1, which is, that's okay, that's normal, and the ST segments they're okay. There's no ST elevation in any of these leads. Okay, and finally the QT looks to be grossly normal. Right, so it's less than half the RR. So we're not worried about this QT. Alright, but to get an exact value, especially if we're concerned that the QT might be short, then we could work out the corrected QT. So this is a sinus bradycardia, which is an otherwise normal ECG. Okay, finally, this ECG. So the rate is 10, 11, 12. So 12 times 6, that's 72 beats per minute. Okay, rhythm. Rate 72, so that checks out. Is it regular? So no, there is some irregularity. So this is a bit narrow, this is a bit wide, this is a bit wide. Okay, more narrow. So it's irregular. But there are P waves before every QRS complex. Okay, what's the P wave axis? It's upright in leads 1, 2, 3, and AVF. That's true, right? And the PR interval looks normal, and the QRS is narrow, right? So what is this? Well, it fulfills all the features of sinus rhythm except for the fact that it's irregular, right? So this is what we call sinus arrhythmia, which is a normal variant, especially in children, teenagers, and young adults. But it can be pathological in the elderly. So cardiac output varies normally with respiration, and as a result, the heart rate also varies with respiration. So it's normal to have mild slowing, right? So mild slowing or speeding up of the heart rate depending on the phase of the respiratory cycle, and this results in this phenomena that we see on this ECG called sinus arrhythmia. All right, so we have a 72 beat per minute ECG with sinus arrhythmia. In terms of the axis, so lead 1 is upright, alright, lead 1 is upright, that's a thumbs up. Lead AVF is upright, so that's a thumbs up. So that's a normal axis. P waves are grossly normal. So this ECG does not have the precordial lead, so we are limited in our interpretation. Nonetheless, so this ECG was mainly to demonstrate the sinus arrhythmia. But on the leads we can analyze, the P waves are normal, the PR interval is okay, the QRS is narrow with a few septal Q waves in the inferior leads, right? The QRS is narrow, the ST segments are isoelectric for the most part. Yeah, they're isoelectric, and there are the only T wave inversions. Actually, there are no T wave inversions. Well, only in AVR, right? And the QT interval I would say it's grossly normal, or maybe it's borderline. So let's calculate that QT interval, right, with Bazet's formula. So we're gonna measure the QT. So this is a little bit challenging, right, because of the fact that this rhythm is a little bit irregular. But what we will do, so for whatever QT we're measuring, we measure the RR interval for that same cardiac cycle. So because the RR interval may vary a little, so we'll pick this one. Let's measure the QT. So it ends about here. All right, so this QT would be here to here is 0.2, and let's add 2 tiny boxes, so that's 0.28, and then 1, 2, 3 tiny boxes, that will be 0.12, so it should be about 0.4, right? So our measured QT is 0.4, and our RR now. Okay, so that's 0, so 0.2, 0.4, 0.6. all right, 3 small boxes, so that would be 0.72, and let's add 2 small boxes from over here, so that'll be about 0.8 in total. All right, so that's the RR. So the corrected QT is the measured QT over the square root of the RR. So let's work that out. So the square root of the RR is the square root of 0.8. Alright, so that's 0.89. So that's 0.4 divided by 0.89, and that's 0.449, which is normal. Alright, 0.449 seconds. So that's our QT. So in summary, we basically again have a normal ECG. Thank you for tuning in.